Okay, so we're going to continue with our notes from yesterday. So page 7, I think we got halfway through this problem. Is that right? We didn't quite finish example 1 on page 7. Okay. All right, so let's continue walking through it. Okay, so let's recap what we've done so far. We knew that the first step for anything involving real numbers, we're just always going to do direct substitution, right? Direct substitution, because we want to know, because we don't see the graph in front of us, so we want to kind of have some idea what's going on. And that 0 over 0 kind of gives us an idea that there's a hole in the graph, but the limit does exist. We just have to go about looking for it. Okay. And we're going to go through this conjugate method because we see a radical in that numerator. And so the conjugate is rewriting the numerator with exactly the same thing. The only thing you're going to change is the sign in between the two terms. So this is A and that's B. You're going to write A and B again, but then you're just going to change the sign. If this is a plus, you'll make it a minus. If that's a minus, you make it a plus. Okay. And then whatever you put in the numerator of your you're also going to do the same thing to the denominator. Okay, anything I do to the numerator, I'm going to do to the denominator as well. Yeah.
Every single time it's 0.
Only if it's a radical involved. Okay, like previous examples that we saw was where if I saw something that's factorable, then I'm going to go to factoring and reduce. But if I see radical and you get 0 over 0, at least on the quiz, you're going to be expecting, you know, this is going to be your strategy to move forward. Okay, so just to kind of give you a big picture as to what you're trying, because you know this may look kind of messy with what's going on here, but the big picture is that you're trying to get an x minus 4 to show up in the numerator. Okay, the x minus 4 is already in the denominator. We're trying to find a matching pair in the numerator that's also causing that 0 in the numerator, but that x minus 4 is hidden from view. It's kind of, because that radical is kind of hiding it. So in the end, though, we're hoping that an x minus 4 shows up so that we can get those to cancel out, because we know that there must be an x minus 4 that's causing an issue up top, because that's what's causing an issue below. So we're going to expand. So when we expand, 6 times 6 is 36. The square roots becomes just x plus 32. We talked about how we know the middle terms will just drop out. So we don't have to go through and deal with the middle terms. Okay, so now let's continue cleaning up. Now, you're going to expand the numerator, but leave the denominator alone. And again, the reason why we leave the denominator alone is because we want to pair an x minus 4 with something that is also x minus 4. If we expand, we're going to lose that x minus 4. It's going to be harder for us to cancel out what we've already identified in the denominator. Okay, so we're going to distribute the negative through. So 36 minus x minus 32. Okay, so what does the numerator reduce to be?
4 minus x.
4 minus x. Okay, so technically I should be rewriting all these limit notations over again. Okay, so do we see an x minus 4 in the numerator?
No, 4 minus x is different than x minus 4.
But it's pretty close,
Oh.
right? It's pretty close. Is there anything that I can do to make them the same? Yeah, I can factor a -1 out. So if I factor a -1 out, I mean, either from a numerator or denominator, I'm going to do it from the numerator here. So if I factor a -1 out, that means I can change the sign of what's in my original term. So it's -4 plus x, which is the same thing as x minus 4. So now that I factor a -1 out, I can see that -4 plus x is the same thing as x minus 4. I can reduce. Now in the future, if you realize that these are just off by -1, you can just cancel these both out and just make sure you hold on to a -1 as a result of that reducing. So the hole is gone. Okay, we've removed the hole. The 0 over 0 should no longer be an issue. So let's reevaluate Let's do direct substitution again into our reduced expression. And we should be left with a real number here. So we go ahead and replace x, all the x's. Well, there's only one x here. Replace all the x's with our 4 here. And so 4 plus 32 is 36. Root 36 is 6, and then 6 plus 6 is 12. So that -1 stays. So -1 over 12 is a real number. This is our limit. Okay, so the process that we did from the previous problem is different, but the idea is the same. The idea is that we do direct substitution. If we get 0 over 0, there's a hole. There's some cleanup that we have to do, but ultimately we're trying to find a way to get that matching pair of factors that's causing that hole to appear. We're going to remove it, and then we are going to reevaluate the limit in the hopes of getting down to a real number. Yes.
Like get stuck factoring, so you don't factor it all the way to 50, but then insert the 4, like would you get a different answer? Would that be fine?
Oh, if you don't factor correctly. You mean for this problem or for like a previous factoring problem? I think for this one, we should be able to get this to show up, right? If we don't get this to show up, that means we know that we did something incorrect, right? So you know that if you get a 0 over 0, you know your numerator must produce some version of x minus 4 above, because if you don't get that to show up, then that's a red flag for you to kind of go back and see, okay, what did I do wrong? Because I know there must be an x minus 4 or some version of it that shows up, because I'm guaranteed to have a hole that can cancel out. Okay, let's do one practice of this, and then I want to show you the last type of reducing, which is involving common denominators. So let's turn to page 8. Let's try number 1. I just want to make sure we can have this particular type of procedure where we can practice through it on our own, and then once we feel a bit more comfortable, I'll show you that last type of reducing involving common denominators. Right, but don't skip steps, okay? First things first.
Plug-in.
Yeah, that's right. Direct substitution. What do we get with direct substitution?
0, 0.
0, 0. All right, so we see a radical in the numerator, so we know that conjugate is going to be our method of changing the way it looks in the numerator. So what's the conjugate of my numerator here?
Square root x plus 2.
And whatever you put up top, you're going to copy that exact same thing below. I see some students, they do the conjugate of the numerator and they make it different. So we can't do that. If we multiply numerator denominator different, then we're not multiplying by 1, and then we're changing the overall value. So we want to make sure that whatever you find as your conjugate, that you're copying that term above and below the same. So these should always match. All right, let's FOIL out the numerator. And we know that the middle terms will drop out, right? So really you only have to worry about the first pair and the last pair, right? Because you know that everything else should just go away. There's no need for us to continue to do that if we know they are going to cancel out. Okay, so root x times root x gives us
X
minus 4, and this is already matching with our denominator, so that makes it a little bit easier. Good. So we see what's causing the hole, x minus 4 and x minus 4. Remove them. Now, what's left in the numerator? 1, not a 0, right? There's still a 1 left over. So this is your reduced expression. And now that you have your reduced expression, you're going to reevaluate the limit. We should no longer get a 0 over 0. We should get something else now. We should get a real number. And what do we get? 1 over 4, right? Root 4 is 2. 2 plus 2 is 4. It stays in the denominator, though, so don't just say it's 4. It's 1 over 4. Okay. Any questions with procedure there? Yeah.
Why wouldn't you like, so you don't have to rationalize square root back up to the numerator?
No. Yeah. In this course, you can, but it's additional work that you don't have to do. Yeah. So you're never going to get points taken off if you leave radicals in the denominator. Yeah.
Wait, did you get the x minus 4 on the top again? Like I know you multiply, but how does that work?
Right. So I foiled everything out. So what's root x times root x? X. Right. Because if I multiply 2 square roots together, the square root goes away. I'm just left with what's inside. Yeah. And right. And the -2 times 2 is going to be, now if it was root x minus root x, that would be 0. Right. But it's root x times root x equals to x. All right, good. Any other questions? All right, let's go back to page 7. Okay. Okay, so this is the most tedious. This may take the most practice for us to get used to. This is simplifying by common denominators. And we know we have to most likely involve common denominators when you see this complex fraction with, fraction within a fraction. But first things first, right? We don't want to assume anything. What's our first step?
Yeah, plug in the 0.
Yeah, direct substitution, right? Let's see what's going on here. Because we're never going to do any of these steps unless we get a 0 over 0, right? If we get a real number in return, then that's our answer. If we get a 10 over 0, we say that's limit doesn't exist. The only time we have to do additional work beyond plugging in is if we get 0 over 0. So let's confirm that first. Okay, so 0 in for x. Okay, 1/4 minus 1/4 is 0, and denominator is also 0. Okay, so we know there's a hole. We know we got to continue working on this problem. So here's the strategy here. The strategy is we're trying to, okay, do you see there's an x here? That x is obviously causing that 0. And there's a hidden x in this numerator that we're going to be looking for. Okay, but right now it's a little bit harder to see because we have 2 fractions with 2 different denominators. So the goal is if I can somehow do common denominators and try to merge these 2 fractions together, then I should be able to produce an x that will pair up with this x. Right. So let's focus our attention on just the cleanup of this portion. Okay. I'm going to figure out how can I merge those fractions together. And to do that, I need to find common denominators. Okay, so I'm just going to focus on this part here. So I need to find a common denominator. So what's a common denominator between x plus 4 and 4?
X. X squared plus 4.
Say it again.
X squared plus 4.
Yeah, so I need both, right? You see that x plus 4 and 4 are completely different. This 4 is not part of this 4 because there's a plus sign in between. So if I have 2 different things, and if I'm trying to create a common denominator, I need both to create a common denominator. We don't have to be too creative about it. We just have to understand, okay, those are 2 different things. They're not the same. So I need both to create my common denominator. Okay, so it has to be large enough for both individual portions to go into. Okay, so now we have to balance each fraction. Okay, so look at this old denominator versus new denominator. Okay, what has changed between these two?
An additional 4.
There's additional 4. So I need to add a 4. So I need to include that to the numerator. So I need to multiply a 4 to the numerator in order to balance that change that I did with the denominator. Okay, so I need to multiply the top by 4. So there's 4. Now, what's changed between this old denominator and this new denominator?
X plus 4.
X plus 4. So I need to balance the numerator with an x plus 4 because I did that with the denominator. So x plus 4. Now keep it in a set of parentheses because there's a minus hiding, or there's a minus sitting here We got to make sure we distribute that through. Okay, so now that we have common denominators, we can merge them into the same fraction. Okay, what you don't want to do is you don't want to just start canceling out, because if you cancel out, then you're back to where you are, right? So you want to hold on to that common denominator so that you can put these under the same fraction. So now I have 4 minus x minus 4. So I'm distributing the negative through. So I'm still playing with this region here. Okay. Now, what does this reduce to be?
Minus x.
Negative x up top. So this is now my cleaned up version of what I started with up top. Okay, so I'm going to rewrite my problem here. Limit as x approaches 0, negative x over 4 times x plus 4 all over x. So we're beginning to see some matches, right? This x, that's causing the hole. We see an x appear here, and that's what we're trying to target. Okay, everybody good so far? So do you see how this is a fraction divided by a value? Okay, so this is still a complex fraction. So I would like to get these two to be on the same level. So let's do this here. So if I do a value divided by a denominator, that's the same thing as, so dividing by something is same thing as multiplying by what?
Reciprocal.
The reciprocal. So what's the reciprocal of x?
1 over x.
1 over x. I'm going to bring that reciprocal up to the top. So this is now my way of seeing that relationship between the top and bottom. So if I take the reciprocal of x, it's 1 over x. I'm going to take that 1 over x, and now I have it up at the same level as my numerator. So this feels a little bit cleaner here. Okay, now what do you see? Yeah, so now I know I'm going to cancel stuff out, and this is what I'm targeting, right? I know there's an x that I'm trying to pair up with. I found that x in the numerator. Now I can reduce. Now there's still a what left up top here? -1. So okay, the hole has been removed. We should be able to get a clean number here. What's our final step?
Plug in 0.
Okay, plug in a 0.
-16.
Good. -1 over 16. All right, so this requires a bit more work and steps, but we'll get a lot of practice with that today. Yeah.
You did like write down, like you did like keep writing the limit over and over again. I mean,
Yes, yeah. So the rule of thumb is, as long as there are still variables remaining in your expression, that limit still needs to be there. Yeah. As soon as your expression are replaced with all numbers, then your limit notation can drop out.
So would we get marked off on the AP exam? We didn't have to limit it.
That's up for debate. It depends on what they decide on, because they always have training for a question before they let the graders start grading. So, but
I probably just assumed that they would.
maybe, yeah. So sometimes, yeah. So, but typically, these problems don't show up necessarily on the free response in terms of just finding the limit. This type of problem tends to show up more on multiple choice. So, but so the answer is maybe. If it does show up, maybe they'll be picky about it. But yeah. Okay, there's one more thing, that's squeeze theorem. Squeeze theorem is, I think it's pretty easy, but let's save that for later here. Let's get practice with this. I think this is the most algebraically most involving of the problems that we've done. So,
Would you mark on all this?
I'm sorry.
Would you mark all that?
I would say that I will give you a reminder on the test to do it. So if I give you a reminder, then I expect you to do it. Okay, so let's try number 2. And again, if at any time you feel like I'm not giving you enough space for you to do your work, you can find another sheet of paper to extend to have more space, or you can always grab the printer paper that I have on the shelves. Okay, so let's try number 2, and let's walk through the steps here again. Okay, so number 2, first things first.
0,
0, 0. Okay, look at the denominator. There's an x. So that should tell you that there's an x hiding up here that we're going to look for, but we're not going to be able to find it until we do common denominators and merge them together. So I'm going to focus my attention again here. Okay, the hardest part here is balancing the denominator, finding common denominators and then being able to balance the numerator here. What's my common denominator?
x over x plus, 3 over x plus 3. 3
Well,
times x plus 3.
Yeah, 3 times x plus 3.
Sorry.
Okay, we look at this old denominator versus this new denominator. What has changed, or what's been added?
3.
A 3. So I need to multiply a 3 to the top of my first fraction. 1 times 3 is 3. What's changed between this old denominator and this new denominator?
X plus 3.
X plus 3. So I need to multiply an x plus 3 to the top of my second fraction. Again, there's multiple things coming after the minus sign, so protect that with a set of parentheses. Again, the 3's will cancel out nicely. There's a negative x that shows up. So very similar pattern from what we saw. Okay, let's bring that denominator up to the top by turning it into a multiplication problem. But if I do a multiplication, I need to flip that x to be the reciprocal. X is canceled out just like before. Okay, replace all the x's with 0.
I promise this is the last question I have about this, but
No problem.
so if you're solving for the numerator, you don't have to bring a limit over for that. It's just a numerator. It's only like.
Yeah, so here I didn't put a limit here because I'm just trying to. I stepped away and I just wanted to do some cleanup along the way.
Okay.
And I knew that I was going to come back to this problem, but I was solving a different problem here. So here I didn't bring the limit over because I wasn't doing the limit. I just wanted to get that numerator to be a cleaner version.
Okay, thank you.
Yeah. Okay, so the 3 big algebraic methods involved here, if you get 0 over 0, is factoring. Number 2, conjugate method, and number 3, common denominators. Okay.
Factoring most common.
I mean, yes, but you're going to see all 3 on the quiz.
Factoring, conjugate, and then.
Yeah, factoring, conjugate, and common denominators. All right, so let's try number 3. Let's see if we can get through the rest of this page, and I think that will kind of give us a. Then that's where your quiz will cover. Your quiz will cover the algebraic limits from an algebraic perspective, graphing, and then table of values. But table of values, I'll give you all the values filled out. You just have to look at the y values and see, okay, are the y values taking me towards the same number? If it is, then that's your limit. Okay, let's try number 3 here. Now, I'm going to be looking for your first step for every one of them, okay? So if you go through factory and get the answer, but you don't show me that you're getting a 0 over 0 to begin with, I may take a point off for that. So just make sure that you're always showing me that you are doing direct substitution before you commit to any other steps. Yeah.
Can we just put 0, put like an arrow and then 0, 0?
Yeah.
Do you want us to put actually like right out?
Yeah, right. No, yeah, you can do the calculations in your head,
Okay.
but just show me that you are checking and confirming this 0 over 0 before you do anything more. Because if it's a real number, you can stop and say that's your limit. If you get 10 over 0, you can also stop and say the limit doesn't exist. You only have to go through these 3 steps we're going through if you're getting a 0 over 0. If you realize there's a hole in the graph, but the limit still exists, each time found again. Okay, so number 3, you're going to get 0 over 0. So you know this is a factoring problem. What's the GCF that we can take out?
X over 2, x to the second.
X to the second, yeah. So once you factor out that x squared, they can cancel out between numerator and denominator, reevaluate, and that will take you to a real number. Okay, questions? Right, number 4. Okay, try number 4. Okay, first things first, direct substitution, confirm it's 0 over 0. Once you do that, then radical is involved here, so conjugate method.
Plus.
Expand the numerator, but leave the denominator alone. The denominator is ready for you to pair and reduce. Don't lose that x minus 16 below by expanding that denominator out. Okay, questions with 4? Number 5.
Three factor.
Yeah, so this is trinomial factoring.
Okay.
Yeah. Yeah. Should be 0/0. So 16 minus 24 is negative 8. Multiplies to be negative 44, adds up to be 7. 11 and negative 4. Okay, number 6. Let's start off with direct substitution, and then you see the radical, so you know that most likely involving the conjugate method.
Let's see. The word conjugate method is like a whole numerator. It's not just like a square root.
Yeah, it's got to be the entire numerator. Because this is kind of like A, that's my B, so I need to figure out something that is conjugate of those two terms. So it's going to be A plus B. Any questions? If you have anything that you're still, that you're unsure about, be sure, yeah, just make sure you ask. Yeah, any questions?
Access could be connected to.
Well, I had the same question. Yeah.
So here's the thing is that, you can cancel out across multiplication. So if I have 2x over 3x, this is fair game. I can do this. Okay. What you cannot do is if it looks like 2 plus x over 3 plus x, this you cannot do. Okay, you can never cancel across addition or subtraction, but multiplication, division, that's fine. You do this.
So it's addition and subtraction, you can't, but it's multiplication and division, you
You
can.
can, yeah. And maybe this can convince you a bit. Okay, let's say I had 2 times 3 over 4 times 3. Right, if I multiply this out, this is 6 over 12. Right, is that the same thing as 2/4? It is, right? What if I had 2 plus 3 over 3 plus 3? Right, this gives me 5 over 6. Right, is that the same thing as 2/3? That's not the same thing, right? So that's why we can't do that. All right, number 7, back to fractions where we have to find common denominators. The complex fractions, so, but first things first, right? Always convince yourself you're getting a 0 over 0 before you do any of these additional steps.
Two positive x's change.
Um,
Cause I think the other one did like 1 negative 1.
what's the other one? The one negative one? Yeah, so well, I canceled out the x's, but the negative 1 stays, so that's why there's. If I cancel out an x and x, there's a 1 that remains, but
So when it's like, when it's like 4, the negative is a 4 of those.
right, because I'm adding those terms, right? But if I'm dividing something, I can cancel them out.
Bottom multiply. So
Uh, just divide. Right, just divide. Here I'm dividing, right? Because it's the same thing as x divided by x. So x divided by x will just become 1. But if they're on the same level, then you will do x times x, which will make it x squared. But we don't see that here. Okay, last one, number 8. Getting that 0 over 0 to begin with. Multiply by the conjugate. Number 8 requires a bit more work because after we expand the numerator, we're left with x minus 5, and that x minus 5 is not quite appearing yet in the denominator. So we have to dig a little deeper here. X squared minus 25 can be factored a bit more. That's difference of squares, x plus 5, x minus 5. Now I can get that denominator to show me that pair that I'm looking for. So the x minus 5's canceled out. There's a 1 left up top. There's an x plus 5 and the root x minus 1 plus 2 below. The whole has been removed. You reevaluate your limits. You reevaluate the limit with the expression at x approaches 5, and you get 1 over 40.
Is that the most complex you can get? Is like you have to factor that out.
So you guys have some homework from page 99 to 102. Again, this is a couple problems as well as AP practice. There's one more thing I haven't gone over, and that's squeeze theorem. But that's quick. We're going to get through that in 5 minutes, and we'll spend the rest of tomorrow doing our quiz review. And then Friday, I will also have 7:15, 7:30. I will also have a morning help session going over another review worksheet. Okay. All right. Come and get phones.
Is squeezing like pretty simple?
That's pretty easy.
I mean, I can like go ahead on my own. I
think so. Yeah. If not, I mean, it'll take you maybe 5 minutes to go over it.
Oh, I didn't check my phone, it's like, really.
Okay.
I just did it.
Okay. Great.
What?
Great.
The price list, I lost it.
49 to the 40.
Yeah, I did 49.
But it was good.
Right. 49.
Oh, it's to 49?
Yeah.
Wait, I might have done it wrong.
It says 31 to 49.
Oh, is that sarcasm?
No, I can just show me
I
later.
mean, I like it.
This is page.
I mean, the phrase deep talk was really good though. Those are pretty.
Oh, you did do that. Okay, that's fine. Okay, great. Thank you.
Do this one, like, so I don't mess up with the homework.
Yeah, sure. So this is page 99 to 102. So 53.
Like music theory price.
So that's not like the
So
whole
they
page.
just used to get-
No, right. Don't look at the pages. The page is just so that you kind of know where to look,
Okay.
but then you're going to look at the problems I asked. So 53, 59, 85, and 89. And then AP practice 1 through 8. I should have that in the back. AP practice. Yeah, page 102. And 102 is within that range, so that's at the back of it, so 1 through 8 right there.
Okay.
Mhm.
That's
That's fine, thanks.